Hello, hello, and welcome to day 27 of this Unity Game Development Journal. So, we are moving along here in week 4. It's the last main day of week 4. Tomorrow I'm going to clean up some stuff maybe and work on some final map illustrated sprites and things like that, creating the sprite sheet. But let's talk about how I ended off this week. So, yesterday I had everything up to characters being put onto the map and into the world. I had collisions working, and all that was left was creating some sort of a database to, instead of just putting characters on the map, I want to just put prefab objects onto the map. So it could be anything that's a prefab game object. So I've changed that system over to be a layer for prefabs, and essentially the prefabs will take a tile ID and just map that using a database over to a prefab. So I have on here a save point and a trash can, similar to the way we had the map last week. So those two items will be spawned or instantiated in those locations, those tile IDs. Actually, those coordinates, not tile IDs. Um, the players that I have here will still be counted on that layer, but I'm not instantiating them. It just skips those because we don't have prefab set up for them. But eventually, once I have a full prefab list of all the different items and characters, it'll just grab that prefab and stick it into the map. So that's how that's going to work. Another thing I did was I expanded the collisions layer to now use some other tile IDs. You can't tell it's all looking the same, but essentially there's two other tile IDs here, one for the sand and one for the water. And the way I've modified these scripts is that it uses those tile IDs off of the collision layer to set movement cost. So anything that is this tile ID, which is the rocks here, will have a movement cost of 0. And anything with the sand will have a movement cost of 2. Anything for the water will have a movement cost of 3. And how movement cost works is 0 represents a tile that you cannot move on. The movement cost is 0. Maybe it's a bad description, but essentially it just means you can't move there. Now, if there's a movement cost above 0, such as 1, that means that you can move on that tile, but there is a cost to it. And the way I calculate it is I take the character speed and I divide it by the movement cost. So on any tile that you can move on, the base value is 1. So I take speed and divide it by 1 and you're left with just speed. So you can just move freely on those tiles. Now, tiles such as sand and water, I want the character to be slowed down, whether it's the player character, NPC, or anything. I want them to slow down on those types of tiles. So I set the movement cost to 2 and 3. So what it does is it takes your speed and it divides it by that movement cost. So divided by 2, it cuts your speed in half, or divided by 3, it cuts it in third. So that's essentially how the movement cost system works. It's very easy. No physics are involved, just the plain tile layer. It's a CSV file. I just read it in and I set a movement cost based on whatever I read in at the world creation time. So let's take a look at some code here. What I've done is I've taken the tile type, which we've used for since day 1 of this week, and we have like an empty tile, a wall tile, a sand tile, ground, water, swamp. Right now, the number here is not the movement cost. What it is it's a tile ID mapping. So these are just essentially an enum is just an organized list of integers. So I'm just mapping an integer to an actual like word. So in this case, wall, sand, ground, water, swamp. These words don't mean anything, but in the code you can actually refer to them. And it's just a lot easier to read the code in that case instead of saying, does this tile equal 1? And you're like, well, what does 1 mean, right? But if you say, does this tile equal a wall? Then you're thinking, oh, I understand now. So that's the purpose of an enum. So that's how I'm using it here. I'm using a word to describe a tile ID. And these tile IDs come straight from here. So this is the collision tile 1, tile ID 1. I have sand or something here, 42, and water 43. Maybe I had those backwards, but so you have 42 and 43. Yeah, I did water and swamp, so that's that. Ground was 8, and these are just tile IDs. These will change once I get my final tile set, but it's a way of organizing this. So in the world creation here, actually we'll go back here, the world model here. What I do is I simply go through, I don't think I'll have a lot of different types of tiles for movement costs. It doesn't make sense to have a ton of them. Maybe 3 or 4 would be the final number. So all I do is just do an if-else statement, or I probably will end up doing a switch statement. It's a lot smarter to do that. And I set, based on whatever the tile is, sand, water, and I convert it to an integer. I just set a movement cost for that. So if it's sand, the movement cost is 2, water, the movement cost is 3. Anything else, the movement cost is 0. And that is based on being in the collision tiles dictionary from the parser. So this isn't going through every single tile. It's only going through the ones that I paint on that layer. Now, if I didn't paint anything on that layer, that means that the movement cost is 1, which is the default, I believe, up here. Actually, that's the default in the tile model. Right here, movement cost defaults to 1. So anything that I don't touch or set as movement cost, it just, you can walk on it at normal speed. So that's that. The initialized objects is what I do here instead of the characters, which I did yesterday. So I just changed that to a new method called initialize objects. I come down here to initialize objects, and all I'm really doing is going through the dictionary from the parsing data and grabbing any objects that I put on that layer and saying from the database, find by tile ID, which is a database I set up. I'll show you that real quick. So in here, databases, we have prefab database. So I just set, right now I have 2. I have a tile ID mapped to a prefab. So tile 89 is mapped to a save point. Tile 90 is mapped to a trash. And that's very easy to configure once I get a final tile set in place. And back to the code, it just says grab the prefab data, that object, that database data, based on the tile ID. So it just grabs it based on this ID that I'm looking for. And then it says if there is data in there, or if the prefab is set, then instantiate the prefab right here at the location of that dictionary's key, which is a vector2 coordinate, and rotation of nothing, just the plain old 2D rotation. So that's that. And that's instantiating the objects based on whatever is in this dictionary from the parser. Simple, simple, simple. Movement-wise, I think, let's just check the movement. So character movement, all I'm doing here, I did tweak this. Right after speed, I got rid of this code in here that was checking for overridden speed. So I don't need that. All I'm doing is just getting a movement cost from the world controller's world instance. I get the movement cost based on the character's position. So wherever the character is positioned, I check what tile that is, and then get that tile's movement cost. If the movement cost is less than or equal to 0, meaning that I shouldn't be moving because the movement cost is 0, I set the speed to 0. And then else is I set the speed to whatever the speed was for the character divided by the movement cost. So either 2 or 3, that's set up right now. And then that is where I set the velocity. Now I want to rewrite all of this because I don't really like the fact that it's using velocity to move the character, but for now it's working, so I'm just going to leave it. But eventually I'm going to rewrite this movement thing to stay away from velocity and do it a different way. But anyways, that's besides the point. Let's go ahead and look at all those code changes that I worked on today in practice here. So it generates the world. We come up here. Now I'm in water, so the movement cost is going to be quite slow. I'll come up here and I can move a little bit faster. Maybe you don't notice it as much. There's slow, a little bit faster, and then up here you can really get moving, right? So I come down here, slow, and then slower. Slow, okay? So you can see the movement cost working perfectly. Again, only tiles being driving all this data, right? There's nothing to do with Unity at this time with physics or anything. It's just saying what tile am I on and change the movement cost, the movement speed, I mean. So there you go, and the collision still works perfectly. You can see over here we have our save point in our trash instantiated, the prefabs. So I can even go in, you can see their prefabs here. I can turn them on and off like this. They aren't affected by affecting the map at all. The map is done below them. These are just prefabs stuck on top of the map based on that tile location that I specified in the tiled program. Alrighty. So the last thing I'm going to talk about is what I'm going to work on next for this mapping. And it's probably the last big issue before I can design the whole world. And that is the dilemma of how bridges work. Now, a lot of games either put bridges in or don't, depending on if they can solve this issue. It is it is a way of it does take some thought on how you're going to actually do this. And a lot of people talk about it online, and they get into really complicated things. Like I've even heard people say build a 3D world and then convert it over to like view it as 2D so you can get this to work. And I'm thinking that's ridiculous. That's a lot of work for no reason. Why are you building a 2D game? Why don't you just build a 3D game in that case? And it does work because back in the early 80s, Zelda was doing this like in Zelda 3. That was their main thing. They did levels and bridges and things like that. So let me just explain the concept here. In the base tiles, I'll just grab something random here. We'll just grab this tile here and make a bridge. So let's say we have these two pieces of land and we have a bridge coming here. Now, essentially we want the character to be able to walk on the bottom level here, walk towards the bridge, and then when they get here, they just walk underneath the bridge and keep on going, right? Nothing stops them. They're hidden by the bridge because they're walking underneath the bridge. But when they're walking over here from left to right, they're going to go across here, and you want them to be on top of the bridge now and walk through. So that problem right there of having the different levels can be solved fairly simply by changing the player's layer that they're man, my brain just went here, but the layer that they're actually drawn on. So you can change the sorting layer. I'm trying to think of here. So you can change their visual sorting layer and move them up in the sorting layer. So they're walking on top of the bridge. And then when they're not on the bridge, you can move their sorting layer to be below the sorting layer of the bridge. So now they walk under the bridge. Easy enough. Now the problem comes when you're walking on the bridge and then all of a sudden the character wants to turn up and down. They can just start walking up, right? But it doesn't make any sense. If they're on the bridge and we've changed them to be higher, like on the second floor or something, they shouldn't be able to just walk straight through because that's the first floor. We have to be able to stop them, unless that's designing your game where they can jump off the bridge. That's a whole other ballpark. But essentially, if you have a bridge, you're going to want most of the time a way that they can't walk off the bridge, right? They're crossing a bridge because there's a ravine or something. So then you get into the problem where if we have colliders on the side of the bridge, it stops the player from moving off the bridge when they're on top of the bridge, but somebody on the main level here when they're walking will get stopped by those colliders. So that's the issue. So the way I'm going to solve this is I'm going to put some triggers on the bridge, on the start and the end of the bridge. So they're going to be flip-flop triggers, so they're going to either turn something on or off in the opposite state that it currently is. And to explain that a little bit better, I'm going to say when they come onto the bridge, a trigger will set the player's sorting layer to be above the bridge. So that'll be the first set. And then it'll also enable the colliders on the bridge. So it's going to enable these colliders there. Now they're going to walk across and they'll bump into the colliders, and when they exit the bridge here, that next trigger is going to flip whatever was set. So it's going to turn off the colliders and turn the sorting layer down to the main floor. And it's going to do that whether they come on and then go back off the same way. That trigger will just flip whatever happened to either be on or off, or the upper level or lower level. And that's essentially how I'm going to tackle that in the code. Hopefully that's going to solve that issue. Now what I just described there works in a single player game. It doesn't work in multiplayer games where you have this player up here and they turn on the colliders, but if there's another second player down here walking, they're going to get stopped by the colliders. So if you have a two-player game, you're going to have to think of another solution where the collider is only affecting the player that turned it on, and the second player does not get affected by it. So that's a much more complicated issue, but since this is a one-player game, my solution that I'm going to try and implement is going to fix this bridge dilemma when you're dealing with a top-down 2D game. So there you have it. That's how I'm going to do that. That's my next game plan for this map week. And once that's done, that's pretty much all the difficult things done for generating a whole world and building it into Unity with game objects and things. So thanks for watching, and we will talk to you later. Please subscribe if you're interested, and leave a comment if you have any questions or anything. And if this video was any good, leave a like. Thank you very much. Bye-bye.